Hello everyone, I'm Zitian. Welcome to my presentation of data science project. My supervisor is Dr. Pop James. The title of my project is SIM carving for image privacy. Nowadays, local storage on mobile phones is no longer enough to meet people's needs. Cloud and social platforms have emerged to allow people to store and share their photos. However, there is a huge privacy risk behind cloud platforms, as they scans and classifies images by CNN, so a malicious intrusion into them could compromise the privacy of the image, thus endangering users' personal and property security. So this is why the protection of image privacy in the cloud form is extremely important. The aim of this project is to create an algorithm that modifies the original image in a way to reduce machine learning classification performance without affecting human recognition of the image subject. My work is 10 SIM doppelganger created by Pop by comparing against a modular set of images. And I will also introduce technologies to evaluate restored images by using a similarity measurement. It's also used to simulate human perception. This is the pipeline of the whole project. Input an original image with the pixel distortion, and then goes to the image processing part. The SIMD image is obtained from the energy impact image with distortion using the SIM carving method, and then the image is restored. The random image is used as a reference and comparison with the SIMD image. Next is the evaluation part. The ResNet50 used to test the performance of machine learning. The similarity algorithm simulates human perception to evaluate the effect of restoration. And I also use similarity to compare the ability of machine learning with human perception in SIMD image respects. Finally is the output phase. The first step in SIMD replacement is getting the energy image, which is very important because SIMs will be added in the parts of image where there is less energy information. Pop uses a dual gradients energy function that uses sum of the difference between the left, right, and the top-bottom pixel colors of the center. I use the DOG method for replacement, which uses the different Gaussian kernels to convolve and then subtracts to obtain the energy image. Using the fish as an example, the results of two methods look like this. It can be seen that dual gradients result looks better, so the following steps will be use the dual gradients energy function. For SIM replacement, the shortest path method is used in this section, where horizontal SIMs are detected from left to right and the vertical SIMs from top to bottom of the image. This is an example of finding the shortest path in the vertical direction from top to bottom. When replacing a vertical SIM, the RGB pixel values of the target pixel point in the new SIM is calculated using the east to west direction, the horizontal from the north to south direction by using the equation in step 3 for RGB each channels. This is the SIM image result and 25% distortion. For restoration, by traversing the entire SIMD image, the new pixel colors are calculated using the formula that we have just mentioned. And if the pixel colors are equal to the calculated colors, then they are considered SIM points. In order to make the restored pixel value similar to its surrounding, the average of the two pixels neighbors to it is used as the restored pixel value. Horizontal use north and south, and vertical use east and west. This is a result of restoration. However, the same image are not restored 100% because the intersections of the horizontal and vertical SIMs are modified in such a way, and they can't be restored to a similar color to the surrounding area by using the average. For the evaluation part, I use two sections. One is machine learning part, and one is simulating human perception. Resizing all images and normalizing pixel values to 0 to 1 will reduce the computational effort in the machine learning classification. Using ResNet 50 instance in the TensorFlow and training it in the ImageNet database will output the class, description, and probability. This is a classification result of the seamed image of the fish and 25% distortion. Using the SSIM to generate a similarity by comparing the image's luminance, contrast, and structure to generate similarity. This is the similarity result of the seamed and the restored image to the original perspective. It can be seen the restoration effect is really good. Using the entire fish dataset as a test set and random images as a reference for the effect of seamed image, it can be seen that the classification accuracy of ResNet 50 for both seamed and random images tend to decrease as the distortion rate increases. At 50% distortion, the prediction accuracy is close to 0, but not be 0. And it can be seen that the random distortion images are a little bit effective in confusing machine learning. The similarity of the seamed and restored images of the entire fish dataset is calculated separately from the original images. Simulating the similarity as human perception and observing the effect of image restoration, it can be seen that as the distortion rate increases, the similarity between the restored and the original images is improved by about 50% after restoring the seamed images. So the effect of the restoration is really good, and we think humans are able to recognize the images clearly, as the similarities are about 50% after restored. If compared with the result of seamed images under ResNet 50 and simulated human, it can be found that the classification ability of both human and machine learning decreases as the distortion rate increases. But the human recognition ability is higher than machine learning, and there always have a gap between them. For the limitations and feature work, there are some parts of the project that need to be improved, such as I don't get a good energy image by using DOG method, so this is something that needs to be modified. And the restoration section will find a better function to clean up artifacts better. I will experiment with a large number of real people during the evaluation phases, and it will make the results more realistic. For other solutions for this project, could be use the GNA model to change the image in the generator and then confuse the discriminator, or to override the original image with images from other categories to confuse the machine learning. Thanks for watching.